Yeah, so yeah, let's carry on from where we left off. What's number two? Oh yeah, before I forget, guys. Okay, so just a reminder again. I think I may have shared this or I may have not. I forgot. I don't remember. Okay, but let me just give you one last reminder because we are having our Dominate webinar. Every year we will have Dominate the webinar twice. One at the beginning of the year and one later in term two, I think. And the idea is to basically share with students and parents some strategies, some tips and tricks that you guys can do to actually ace your academic year lah, this upcoming academic year. Okay, so it's going to take place this weekend. Today, evening later, it will be for the primary school students. So if you have friends or family members, okay, your siblings who are in primary school, you can get them and their parents to actually go for this. It's completely free, no charges involved. For secondary school, it will be tomorrow. Okay, and we for secondary, right, we will be okay. I think both primary and secondary we're giving out giveaways. I'm not so sure what's the primary giveaway, but for secondary it will be basically be some questions to help you prepare for your WA1. Okay, I know it's a bit early to think of WA1, but yeah, it's actually just going to be in a few weeks time. I think in week number 6 or week number 7 generally that's where students sit for WA1, right? So you can just get this ebook first for free and then have it as standby so that later on to prepare for WA1 you have some additional questions to practice on. Okay, the questions and the full solutions provided. Okay. Okay, yep. So it's tonight for primary school and tomorrow for secondary school. Okay, 7:45 to 9:15 p.m. Completely free, conducted over Zoom. But you need to register lah to get in the details. Okay. Okay. Yeah. So let's carry on from where we left off. Okay. So let's take a look at we are at. You managed to download already, Imran? Can okay, we are at page number 19. Okay, question 13B. Okay. Now in question 13b, right, let's take a look at this question here. We have tangent 2x equals tangent 2x over to tangent x equals to negative half. Okay. Now let's see what we can do here. Okay. Now as of now we have fractions. So what I would normally do is I'll try to get rid of the fractions first by cross multiplying the two equations there, the two fractions there. All right. So what happens is I will multiply tangent 2x with negative 2. So, or maybe I'll just, okay, maybe I'll put the negative, right, with for the top. Okay, so this negative, I put it at the top. You can do that. Okay, the negative, you can put it at the top, or you can also put it at the bottom. Okay, so I'm just going to, I think it's easier if I put it at the top. Okay, so I will take 2 times tangent 2x equals to negative tangent x. Okay. Okay, now every time when you're solving an equation, okay, it's a trigo equation or when you are working with trigo inequality, trigo expressions, right? One of the things that you have to do is to always look at the angles that you're working with. Okay, now if you look at this equation here, you have a mix. You have two different form of angles. One is 2x and one is x. Okay, now it is not always necessary to go and change the angles. If let's say I have an equation of this form, 2 tangent 2x, okay, and I have maybe okay, so let's say I got this kind of equation, right, guys? Okay, whereby this is tangent 2x, this is also tangent 2x. There's no need for you to go and change them to tangent x. Not necessary. Why? Because of the fact that throughout that equation there, everything is in terms of tangent 2x. Okay, but if you come across what we have at the moment, okay, the blue one, okay, this one, right? You notice that some is 2x, some x. In this kind of scenario, we got no choice but to change everything to tangent x. Can you still remember the double angle formula for tangent 2x? What's the formula for tangent 2x? Let's tangent 2a according to the formula sheet is Numerator is 2 tangent A, right? Denominator is 1 minus tangent square A. So use this to help us. So now that we have, because of the fact that now we have a 2 here, be careful. So instead of 2 tangent A, it becomes 4 tangent 2x. Okay, because originally it's this, right? But you times 2, so it becomes a 4 at the top. Okay, and the bottom would just be 1 minus tangent square, sorry, 4 tangent x, not 2x, 1 minus tangent square x. Can? Okay, now can I get you guys to carry on from here? Then I'll help you out in a while. Okay, but y'all carry on first. Okay, can. What is the next thing that you guys do after from here? Let's get Nazria. Nazria, what do you do after this? Okay, good. You cross multiply. Okay, and the idea is to get rid of the fractions, right? So you have 4 tangent x equals to negative tangent x, okay, times 1 minus tangent square x, correct? Then when we expand this, you have negative tangent x plus tangent cube x. Okay, now Irfan, what do we do next?
I bring the cos over x to the right side.
Okay, good. So we'll have tangent cube x, right? With this negative, with this 4 brought to the right, it becomes negative 4, correct? Then plus a negative 1 here, you end up getting, okay, you all got the same as us. Farouk? Okay, Charlotte and all okay? Can? Okay, what do we do next? Farouk, what do you suggest we do after this?
Substitute 10x is y.
Okay, you can use substitution if you want, but let's say I don't want to use substitution. I just want to work with tangent x. What can I do here? Okay, those of you who prefer to use substitution, you can use substitution. Go ahead. No, there's nothing wrong with that. Okay, but I think it's okay to not use substitution. What do you do next? You need substitution, right? After you substitute, what do you do? Quadratic formula, but this is power 3. You're going to get, in your case, it'll be y power 3 minus 5, right? Minus 5y. What do you do after that? Oh, okay. What shall we do after this? Tangent is a common factor, right? So we can actually factorize tangent out. So don't worry, even though you end up getting although it seems like you end up getting a cubic equation here, okay, but no worries because tangent x is a common factor which you can factorize out. Okay, that will give you tangent square x minus 5 equals to 0. Okay, so remember when two factors equals to 0, what's how to proceed? We apply the 0 product, right? So tangent x equals to 0 or tangent square x minus 5 equals to 0, which is just, or tangent square x equals to 5. Okay, now I want to pause for a moment. Okay, now can we use both sets of equations, guys? Let's take a look at this tangent x equals to 0. Is this an equation that we should proceed? Or should we just stop here for this one? What do you all think? Why? Why can't it be 0? You're right. This one here cannot proceed. In fact, we've got to reject this one here. Okay, but why can't tangent x be equals to 0? What's your reason, Farouk? Or was it just a wild guess? Anyone knows why tangent x cannot be 0 in this context? Okay, tangent x can be equals to 0, guys. If you look at your tangent graph, there are points where tangent x is 0, right? Okay, but why is it that in this context here, for this equation, we reject? Yes, Charlotte? Yeah, Charlotte is right. Okay, when tangent x is 0, what happens to the denominator of this fraction? Guys, what happens when tangent x is 0? The denominator here becomes 0, right? What happens when denominator is 0? Cannot, why? Undefined. Okay, so as I was explaining to the EMF class just now, okay, I was telling them that if you have 0 divided by anything, what is this? 0. Okay, but if I have something divided by 0, this is undefined. Good job, Nazria. Okay, this is undefined. Why? Because you think about it. If you have one pizza, you divide by 3 people, it makes sense. One of us get 1/3 of the pizza. We divide by 4 people, we get 1/4 of the pizza. It makes sense. But how do you divide by 0? How do you divide one pizza by 0? Okay, you're not dividing by 1. Dividing by 1 means you take the whole pizza. But if you divide by 0, you can't even comprehend that, right? It's something that just doesn't make sense. It's not even abstract. It's undefined. Okay? So, yeah, whereas if you have nothing, you divide by 5, you still get nothing. Okay? So, yeah, so the reason why we reject, in this case, we reject tangent x equals to 0 is due to the fact that if you look at the fraction, the original fraction, you have tangent x as a denominator. and tangent x cannot be 0. Okay, so that one we reject. Cos tangent x cannot be 0 there. So you only have this set of equation to work with. Tangent square x equals to 5. Okay, now then this is where I get you guys to help. Haris, how do we proceed from here? When tangent square x equals to 5, how to solve this? What do I do next? Good. So tangent x, we square root both sides, right? Equals to square root 5. Am I correct? Sure? Something missing, right? What's missing, Nazir? Plus minus, yes. Whenever you square root both sides of your equation, don't forget to include plus minus. Okay, now since you have tangent x equals to a constant already, this is where you can draw your quadrants, remember? Okay, draw your quadrants. Okay, and then find your basic angle. Okay, I got one question to ask you. Okay, now tangent x equals to positive plus minus square root 5 means that tangent x can be positive square root 5 or negative square root 5, right? Must I find two separate basic angles for each of them? Think about it. Tangent x equals to positive square root 5 or tangent x equals to negative square root 5. Do we have to find two separate basic angles? No need, right? Because even if tangent x equals to negative square root 5, how do we find the basic angle? We would just take the inverse tangent of positive square root 5, right? We would ignore the negative sign anyways. So both this, whether it's positive 5 or negative 5, the basic angle is going to be the same. So there's no need for you to find two times. Okay, so when you take tangent inverse of square root 5, what do you get? In the degree mode, right? Are we working in degree or radians? Yeah, degree from 0 to 360. So let's work in the degree mode. You find what you get for your basic angle?
65.905.
65.905. Let me double check that one again. Yeah, you're right. 65.905 degrees. So about the same as us. Okay, so basic angle found. Now then we also got to ascertain which quadrants are we looking at, right? Remember, all science teachers crazy. ASTC. Okay, now tangent is positive which two quadrants? Tangent is positive in the first quadrant and third quadrant, correct? Now, also, tangent is also negative here, right? It can be positive square root 5, which is the first and third quadrant. When it's negative square root 5, it's in the second and fourth quadrant. So in other words, it's in all four quadrants, guys. Okay, same basic angle, but in all four quadrants. When it's positive, first and third. When it's negative, second and fourth. Okay, so in this case, you have four answers here. So x would be the basic angle itself, 65.9. Okay, there will be 180 minus basic angle, 180 plus basic angle, and 360 minus basic angle. Okay, so if you've done correctly, these are your answers. To one final answer 1 dp, right? So the next one is going to be 114.1 degrees. Okay, so these are your four angles if you have done it correctly. All okay? Questions to ask? Okay, now if there are no questions, let's jump to the next one. Okay, we're moving on to our formula, guys. Okay, let's do a quick recap. Okay, if I were to do example 11, right? Can you guys look at the equation here? Okay, then this is the domain, right? Now, what do you suggest we do here? Imran, you want to try? How do we go about solving this equation here? Sine function, cosine function equals to 0. Hey, hello Ikari, I just realized you're also in the AMF class also, is it? I just realized, so sorry.
Yeah,
Oh, okay,
I
okay.
joined the wrong link by accident.
Oh, just now. Okay, okay, no worries, no worries. Yeah, do you have the materials that I'm using right now? It's the same as last week.
Yeah, I have it.
You have it, yeah. We're at page 20, yeah. Okay, yeah, Imran, any suggestions how we can do this? Sorry, I think you're mute. I can't hear you. Okay, never mind. I ask Ikari. Ikari, can you help us? How do you suggest we do this, Ikari? Any ideas, Ikari? How do we do this?
Do you have to change the sign
Into?
into?
Any idea, guys? Those of you in class?
Doing cosine apa then divide by cosine.
Yes, good idea. So the cosine function we bring to the right first. You get 5 cosine x, right? And then after this we can? How to get tangent? Correct. You divide both sides by cosine. Okay, so when you divide both sides by cosine, you end up getting 3 sine x over cosine x equals to 5, right? And this will give us tangent because sine over cosine is, yeah, this one here, sine over cosine is actually tangent. So this is actually a strategy that you guys need to kind of like remember or familiarize yourself with. If you have a sine function plus or minus a cosine function and the right hand side is 0, this is what you can do. You bring the cosine function to the other side, then divide by cosine to get tangent. Okay, so can you guys do this quickly? Solve this very quickly for me, then we'll move on to the next one. Okay. All okay? You all got the two angles to be the same as mine? 59.0 and 239.0. Imran and Ikri, okay? Can okay, no, I think it's no problem, right? Okay, can I get you guys to also try practice 14 on your own? Okay, now if you look at this question here, right? Again, you have something quite similar to the previous one. Okay, but this is 2x. And both are 2x. So is it necessary to go and change to x or not, guys? Change or don't change? Don't change because they are all the same. They are both 2x. Okay, so no need to change to make sure they become x sine x or cosine x. Not necessary. Just work with cosine. Just work with sine 2x and cosine 2x. Just that when you take sine 2x over cosine 2x, right? You are going to get tangent 2x. Okay. Can you give this a try first? I'll go through with you in a while. You done, Farouk? Which part are you at? Okay. Ikri and Iman done. Imran and Ikri, you done? Oh, okay. Okay, online students, as usual, if you are done, you can take down my number and then share it with me so I can take a look at your work. Please snap a photo and send me your work via WhatsApp, Imran and Ikri. This would be 2x, right? So you got to divide by 2. Okay, number one, when you divide something by something, right? Let's say 5 you divide by 5, what do you get?
Number one.
You get 0.
Yeah.
So how come you get 0 on the left side? Okay, that's one. Number two, when like I said just now, if let's say you end up getting tangent 2x, is there any to go and change to, let's say I got tangent 2x equals to 5, for example. Why is there a need to go and change to a single angle? Just work with tangent 2x. Remember we've done this before? We forgot. A few practice questions before. Like you had. Where was it? The one we had to adjust the domain, that one. Like this one here, the one that I want you guys to try. Remember 2 weeks ago, we were looking at this, right? Was there a need to go and make sure that we split up the angles tangent 2x and cosine 2x and negative 50? We didn't, right? We just adjusted the domain. So no need to go and change to x, not necessary. Okay, I think our answers are correct. Ready? Yeah. Okay. G360 plus basic angle. That's not the fourth quadrant. It's in the first and third quadrant. So it's this one. So we'll go, what's the thing from 0 until 540, right? So first angle, second angle, then 540 is until here. So 1, 2, 3 angles. Next one. No need to go and change to tangent x, not necessary. Hey guys, remember we did this last week, Farouk? Oh, this is a good example. The tangent 3x one. Did we change from tangent 3x to become tangent x? We didn't, right? We keep it as tangent 3x. Just find your basic angle from there. Then afterwards do what? Just adjust your domain. Then refer to your graph. Remember, this was what we did last time. So same thing over here. No need to go and change your from tangent 2x and use the double angle formula. You're putting yourself through something that's very unnecessary. Okay, so what you should do here is okay, let me just check your online students friends work. Oh, I call you Daniel instead of Imran, is it? cannot hear you. I can't hear you. Okay, never mind. Just I think there's something wrong with your sound settings, Imran. Never mind. There's a mistake there. I'll show you where. Okay. Ikri. Yeah, I think yours is correct, Ikri. Good job. Okay, guys, let's take a look at practice 14. Some of you are still very uncertain of when to change the angle and when not to change the angle. Okay, guys, can I have your attention? Okay, now if the angles are both 2x, right, guys, there's no need for you to go and change the angle. Just keep it in terms of sine 2x. Okay, so you do the same thing as what we did just now. Okay, sorry, let me just change color. Okay, it's you have sine 2x equals to 2 cosine 2x, right? Then you divide by cosine 2x, so you'll get tangent 2x equals to 2. Okay, now once you end up getting this, there's no need for you to change to 2x, because sometimes you'll get 10x here. And don't tell me from 10x you're going to change slowly until to x. Okay, we are going to die before we get to tangent x, honestly, because it's going to be such a hassle. So don't have to do that. Just leave it as tangent to x. So I remember again, I want to recap this, and you guys must remember this. Okay, if you go back to page number, okay, the first page. Okay, that means page number 1. Okay, if you go back to page number 1, guys. Okay, remember I was telling you this right from the beginning. It doesn't matter what angle this is. Whether it's x, whether it's theta, whether it's 3 times of theta, 2 theta plus some angle there. It doesn't matter what it is. The moment you have sine of something equals to a constant, or cosine of something equals to a constant, or tangent of something equals to a constant, next thing you do is to find basic angle straight. Okay, how this affect your answers? How this affect your answers later is that this will affect your domain. Okay, as what we have done before. Okay, I'm going to show you one more time how we do this again. Okay, please go and understand this well. Otherwise, you'll be putting yourself through unnecessary work. Okay, now, so the moment you have tangent 2x equals to 2, the next thing to do is to find our basic angle right away. So we take tangent inverse of 2. What is tangent inverse of 2? Okay, degree, right? So it's 63.434. Okay, now this is not 2x, guys. This is basic angle. So don't put 2x there. This must be basic angle. Okay, now once you have your basic angle, okay, this is where you can then draw your quadrants. Okay, that's one. Number two, okay, because of the fact, right, that now the angle inside your trigo function is not x, but something other than x, which is 2x here, okay, we are required to adjust your domain. Okay, the original domain given in the question was x is between 0 to 270, right? Okay, now I got to multiply by 2 because now I'm looking for 2x. So 0 multiplied by 2 is still 0. 270 multiplied by 2 is 540 degrees. Okay, so where are we starting the domain? Start from 0. Okay, 180, 360, and then you stop at 540. Okay, in other words, later when you scan for your answers, from 0, 180, 360, you stop here. Stop scanning at 540. Don't go and find all the other angles already. Okay, so where are, okay, and then tangent is also positive, right? Because tangent is positive, we are looking at which two angles? Farouk? All science teachers crazy. A, S, T, C. First and third quadrant. Okay, this is where your basic angles are, right? Okay, so when you want to find your angles, this is where, because it's now tangent of 2x, so when you write your angles, it's not x, but rather 2x also. Okay, now, so remember how we start? We start scanning from 0 all the way until 540. So I start scanning from 0, scan. I got this angle here. What's this angle here? This is just basic angle itself. Okay, scan. Okay, you end up getting a second angle here. This is 180 plus basic angle. Okay, and you carry on scanning. So just now we scan once, we got two answers already, right? Okay, we keep scanning again. You have your third angle there. Okay, which is, this is 360 plus basic angle. Now, do I have a fourth angle or not, guys? Is there a fourth angle or not? No, why? Because before I get the fourth angle, I stop at 540, right? So I won't get a fourth angle. So you have one angle here, okay, second angle, third angle, and when I stop here, I stop. I don't get a fourth angle. Okay, so that's where I get that 360 plus my basic angle. Okay, can you understand why we do like 1.5 rounds? Because that's where the domain ends. Imran and Ikri, okay? Can, okay. Farouk, okay? Okay, so Haris, you okay? Can, bear in mind this is 2x, so to find the answer, you must give your answer, you must divide by 2 to find x. Okay, and if done correctly, your answer should be 31.7, 121.7, and 211.7. Same as yours? Okay. All good? Okay, now must remember, guys, okay, so don't see 2x only, or must change to x, not necessary. Okay, if I were to put this as 50x, good luck to you. 50x and you change to x, you take forever. Okay, good luck to you. Yeah, I think not one give you one stack of foolscap papers or not may not be enough. Okay, so yeah, so don't have to do that. Just remember, find your base. What the moment you have tangent of whatever, doesn't matter what this is, equals to a constant. Next thing to do, find your basic angle already. The angle here will just affect the domain. That's all. Then you got to scan accordingly lah, according to the domain. Got it? Okay, now it's 4:48 right now. I think it's a good time to go for a short break. Okay, it's 4:48 right now. Let's go for a 5 minutes break. I'll see you guys at 4:54, Ken. Okay, see you guys in 5 minutes, guys. Toilet bomb. Never been to the toilet before. You want the test? Charlotte not back yet, is it? We wait for her. What do you do first day of school?
I think like the first 1 hour 30 minutes was like sitting in the school hall.
Okay.
Then after that was just
Briefings all this principal talk. Principal miss you guys, never see you all for commands.
then it's just with the form class the rest of the day.
Do what with your form teacher?
What?
Do what with your form teacher for the rest of the day?
Like bonding time,
Oh, okay.
like all the get back to school activity.
Najia, what do you do? Same? Farooq? Same? Haris? Do you all miss going back to school? Oh. As a student, I enjoyed going to school. Because okay, just to give you some context, you'll be like wondering why is Coach Hakim crazy? No, I'm not crazy. Back in my time, I'm 40 years old this year, by the way. So no, 40 years old last year. So I'm turning 41 this year. So back in my time, right, we didn't have much things to do at home. So there wasn't like YouTube. So whatever you watch on TV is basically the free to air shows. You know those Channel 5, just CNA, that kind of thing. So that was the only and then last time we used to watch cartoons on those, like last time they call it what, Kids Central, or I can't remember lah. Yeah, one of those channels there. So you only get to see programs that are free to air. There's no like Netflix. There's no YouTube. It's boring like home. Yeah. So going to school is an opportunity for you to meet your friends, for you to get out of the boredom, because really at home got nothing to do. Okay, you get bored after a while. Yeah. And also my school hours were short. Like even at Sec 4, I was from Swiss Cottage, same school as Daniel. Then even at Sec 4, right, my classes ended at 1:30. Okay, then sometimes I would sit down for like half an hour, all homework done already. Then 2 o'clock I start to play. Then I'll play football every day, 2 p.m. to like maybe 5 or 6 every day until end of school. So school was more fun and less tiring back then lah. So that's why I look forward to going to school last time. Yeah. Okay, but now I understand. You all have so many things to do at home, right? Got Netflix, got all the entertainment. So going out of home is it's not as fun as staying at school. Okay, let's carry on from where we left off, guys. Ikri and Daniel, are you guys back? Okay, welcome back, guys. Okay, so let's carry on from where we left off. Okay, so just now we were looking at these two questions whereby you have sine function and a cosine function equals to 0. Okay, it doesn't matter whether this is a plus or minus, the strategy is about the same as what we did in practice in the example 11 and practice 14, right? Now, what happens if, let's say, you end up getting something like this? If the right hand side isn't 0 but let's say a 2, for example, do you think the same approach will work? If I would bring 4 cosine x to the right and divide everything by cosine, what's going to happen? Let's try this out. Okay, I'll have sine x equals to 4 cosine x plus 2, right? Okay, when I divide by cosine, this becomes tangent x, correct? This becomes 4, correct? Seems to be okay. Let's look at what happens when we divide by 2 by cosine. You end up getting 2 over cosine, which if you change also to become secant, there's nothing that we can do here, right? Okay, you get stuck. Okay, because of this secant x there. Okay, pun intended, yeah. Okay, yeah. So you end up getting this, and you get stuck after this. All right, so so this is obviously not the way to work. Okay, so what we will do instead is, in circumstances whereby this is a non-zero constant, okay, we will actually be using our formula. Okay, now what does our formula do? Okay, now our formula, right, what it does is, okay, I'm just going to jump up to this part here. The derivation is actually not that important. Okay, most of you, okay, I just want to ask you guys, are you guys normally allowed to go from this to this straight away? Most schools are okay with that. Very few schools I know that I know of some schools whereby they are Yishun. Anyone, one of you from Yishun Town here? Yishun Town, from what I hear from my previous students, yeah, even last year's batch, they were told to actually show the derivation. Okay, I'm going to skip the derivation. Okay, I'm just going to jump to the formula itself. Okay, so what our formula does, right, guys, is that it combines a sine function and a cosine function. Whether it's a plus or minus, it doesn't matter. You can actually combine it to become one sine function instead of having two trigo functions. Or if you prefer, you can also change excuse me, or if you prefer, right, you can also combine it to become a cosine function. So depending on what you want. Okay, so if normally if you want it to be a sine function, I will put sine as my first term. Okay, so the coefficient of your first trigo function will be A, the coefficient of your second trigo function will be B. Okay, if you want to change it to cosine, then you put cosine as your first function. So the coefficient of that first trigo function will be A, B will be the coefficient of your second trigo function. You guys okay? Now, one thing to take note is that if you're changing to sine, okay, the sign, right, SIGN, plus or minus, will follow. If this is a plus, inside the bracket will be a plus. If this is a minus, inside the bracket will be a minus. Okay, but if it's you're changing to cosine, then you have to be careful here because for cosine, the sign alternate. Okay, if this is plus, this is minus, minus, plus. Okay, now your job is to figure out this value of R and alpha, which you can find. Okay, R can be obtained from this formula here. It's actually just the square root of A square plus B square. Okay, alpha, okay, this is not A, this is alpha by the way. Alpha is just the tangent inverse of B over A. Okay, now let me show you an example. Okay, let's take a look at example 15, guys. Okay, sorry, example 12. Okay, now the question wants us to express this plus this as a single trigo function. Okay, so let's do that. Okay, so we start off by writing 2 sine x plus 5 cosine x equals to, okay, let's just, since we have sine as the first term, right, let's just combine this as a sine function. So R sine of x plus or minus, guys? Plus, right, because it follows the sign of this one here, should be plus alpha. Okay, so this is your starting point first. All good? Okay, now your job is to figure out what R is. So R is just the square root of your A square plus B square, right? What's our A here, Haris? 2, and B is, Charlotte? 5. So A square is 2 square, B square will be 5 square. Okay, now this is 2 square plus 5 square is 4 plus 25, which is 29. The square root of 29 isn't a nice number, right? It's an irrational number. So just leave it in its exact form. Leave it as a set. Okay, leave it as square root 29. Now, if you, in this case here, 29 is a prime number, so you can't simplify this. But if let's say you come across sets like this, for example, I come across maybe square root of 80, for example. Please simplify this, because square root 80 we can simplify, right? 80, what's the largest factor of 80 that's a perfect square? 16. Okay, yeah, so it's actually square root 16 times square root 5, right? Because 80 is 16 times 5. Okay, and square root 16 is 4. So you simplify to 4 square root 5. Okay, yeah, so you try to simplify as much as you can. I'll explain to you why later. Okay, so R we've already found. Alpha. Alpha is tangent inverse of B over A, right? What's your B? Farouk?
5.
5, and A is 2. Yeah, so take tangent inverse of 5 over 2. You are going to get 68.198 degrees. Okay, so 2 sine x plus 5 cosine x is just the square root of 29 sine of x plus 68.198 degrees. Okay, now typically, right, guys, in the final answer you round this to 1 dp. Okay, but this is not like the final answer, right? So I'm just going to leave it like that lah. Okay, so just replace your R with square root 29, replace your alpha with 68.19. All okay? Can? Okay, now not done yet. They said that hence, so I'm using what we have found just now. Okay, we are asked to state the maximum and minimum values of this function here and the corresponding values of x between 0 and 90 degrees. Okay, now so let's look at this one here. Okay, now to find the maximum and minimum values, right, it's actually quite straightforward. Okay, I want to ask you guys this question here first. Okay, this is not going to be, okay, maybe I just show you this part. Give me a moment. Let me just. Okay, now let's say you have sine x, right, guys? You still remember what's the maximum and minimum value of a sine function? Maximum is 1, minimum is -1, right? Okay, this applies to all to sine as well as cosine functions, correct? Now, it doesn't matter if this is x plus 68.198. Okay, maximum and minimum would still be at 1 and -1. Okay, you don't have to know this, but this plus 60, when I add this 68.198 into the graph, right? Okay, this is not something that you need to know, not in your syllabus anymore. Used to be in my syllabus last time when I was an O-level student. Okay, but you now don't have to know. This basically shifts the graph to the left by a certain units. Okay, but it doesn't affect the maximum and minimum. Okay, now so what happens when I include this when I multiply by square root 29? Okay, now maximum will also be multiplied by square root 29, right? You get positive square root 29. Minimum -1 also multiplied by square root 29. So you get negative square root 29. Okay, so what's the maximum? You can see, right? Square root 29 is the maximum. Minimum would be negative square root 29. Okay, now I need to, finding the maximum alone is not enough because they also want you to find the corresponding values of x. In other words, for us to get maximum, right, what's the x angle? What's the angle for x that will give us a maximum value? Okay, now to do this also is quite simple in the sense that you don't have to do much calculation. You just have to think of your original sine graph. You all still remember how your original sine graph looks like? Haris, how to draw the original sine graph? Let me zoom in here. How to draw the original sine graph? Haris, you still remember? How? Sine graph starts from? If I'm drawing from, if I'm starting from 0 degrees, where does my sine graph start from? 0, right? Then go up, okay, mountain and then hill, right? Yeah. Okay, this is 360 degrees, correct? This is 180, this is 90, and minimum is at 270. Okay, maximum happens at 1, minimum is at -1, right? This is your original y equals to sine x graph. Okay, now at maximum, okay, we know that for maximum to happen, okay, angle must be 90 degrees. So sine of 90 gives us maximum, agree? Now, same thing over here. For this to be maximum, right, this angle here must be 90 degrees because sine of 90 gives us what? Okay, so to find the corresponding value of x, what we do is we let x plus 68.198 degrees be 90 degrees because that's where maximum happens. Can you understand? Okay, and then therefore x must be 90 minus 68.198. Okay, which is going to be 21.8, right? Degrees. You guys understand? So maximum happens at 21.8. Okay, now what about the minimum, guys? Okay, minimum value. What's your minimum value, Farouk?
Negative 12.29.
Good. Okay, now and according to the graph, right, for us to get minimum at -1, what must the angle be?
270.
270 degrees, right? This x must be 270, which means that for us to get minimum, this must be 270 degrees. Okay, so x equals to, sorry, okay, which means that x must be 270 minus your 68.198. Okay, that will give us 201.8 degrees. Am I correct? I think there's a typo in the question. Can you change this between 0 and 360? Can you go back to the other? This is between 0 to 90, but not possible. If minimum happens when x is at 201.8. Okay, questions to ask? Ikari and Daniel, okay? Okay, now. Okay, so yeah, so so R formula, right, guys? Okay, it's useful. Just now I've already showed you using the R formula. Okay, we can actually do this. Okay, we are able to find the maximum or minimum value. Okay, through by combining, because if you look at them separately, it's difficult to guess what's the maximum minimum, right? By combining them into one trigo function, it makes it easy. Okay, so our formula helps us to find maximum and minimum. That's one. Okay, number two, it also helps us to solve equations. Okay, so let's look at another example here whereby we use our formula to help us solve an equation. So let's take a look at example 13. Okay, yeah, so can you guys do the R formula for me for part 1? Okay. Find out what's your R, find out what's your alpha first. Okay, bear in mind this one is in radians, guys. How do I know it's in radians? How in the world do I know that this is radians, guys, and not degrees? You look at the domain, right? Okay, the domain for alpha is from 0 to pi over 2. Okay, so this is an indication that this is in radians. Alright, so if done correctly, your alpha should be 0 0.6, sorry, 0 0.6 4350. And yeah, so okay, can, because in this case we're supposed to express it in the in the final form, and because this is like a final answer for part 1, right, you need to therefore leave it in 3 SF lah. Yes, sure. You know where the toilet is? Okay, you get Shazwan to show you the way. Yeah, all right.
You need to put like the red compartment.
Oh no, okay. Very good question now. Is it necessary to put radius for radians for angles in radians? Answer is no need. Radians, if you put an angle, right, as just 5, the moment there's no degree, right, it is interpreted to be in radians already. So let me, yeah. Okay, so that's why if you never put degree, it's interpreted as radians. So if you want it to be in degree, you must put degree. If you want it to be in radians, you just leave it, because yeah, as long as there's no signs there, it's interpreted to be radians. Like the one in our domain, notice they don't use degree or they don't put radians, right? So this is understood to be in radians. Okay, can? Okay, so you're got the same as me for part 1. Okay, now moving on to part 2, this is where we solve the equation. Okay, in part 2, okay, when you solve the equation equals to 4.5, so basically this can be replaced with what we gotten just now, right? So I'm just going to replace that with 5 cosine theta plus 0.644. Okay, equals to 4.5. Okay, now what do we do here? Haris, what do you suggest we do now? Okay, sorry, I should use the 5 SF answer. So to make it more accurate, right, I should use 64350. That will make my answer more accurate. Okay, yeah, so Haris, how do we proceed from here?
5 divided by 5.
Okay, we divide both sides by 5, right? So to make cosine the subject, because after this, what can we do?
Cosine.
Yeah, we can find basic angle. Okay, we divide by 5, and from here you can find your basic angle. Okay, now I would typically we will use alpha, right, to represent basic angle, but in this question we already have an alpha used to represent this alpha here. Okay, so don't use alpha again, just write basic angle lah in this case. Okay, because alpha was already used in part 1. Okay, so we find basic angle, we take cosine inverse of 4.5 over 5. Okay, my basic angle is 0.45102. You got the same as me? Okay, now again guys, remember the fact that now the angle is not just theta, this would require a adjustment of the domain, right? Okay, we adjust the domain here because of the fact that now it's not just theta but theta plus something. Okay, so I need to adjust my domain, okay, and draw my quadrants as well. Maybe let me just draw the quadrants first. Okay, and then adjust my domain. Okay, my original domain was from 0 to pi over 2. Okay, but the question wants me to have the equation that I have, theta is plus 0.64350. Okay, so now we must add that 0.350 to your pi over 2, which is going to be pi pi over 2 plus 0.64350. Okay, it's 2.2142. Okay, you are the same as me. Then the left hand side would be 0.64350. You guys understand my adjusted domain, how I got it? Ikari and Daniel, you guys okay? You understood how I got the adjusted domain now? Okay, now, so what we're looking at now, right, the start of the domain isn't at 0, but the start of the domain is at that 0.64350, which is somewhere here, guys, somewhere in between 0 and pi over 2. Okay, that's the start of my domain. And because it's 90 degrees, right, it's until 2.21, which is somewhere here. Just after the basic, the pi over 2, but before pi. Everyone okay so far? Okay. Now, so what I need to do next is then to go and find out where the angles are located. Okay. Now, bear in mind that cosine here, guys, is positive, right? Cosine is positive here. Okay. Cosine is positive. So, which quadrants are we looking at? Irfan? Okay, first and fourth. Now, for the fourth quadrant, I can draw anyhow. It doesn't matter because fourth quadrant is, there's no dotted lines there. So you can just draw anyhow. Now, but for the first quadrant, right, I need to ask myself, should I be drawing below the dotted line or after the dotted line? Should it be 1 or should it be 2? What do you all think? Can you guys show me your fingers? 1 or 2? Don't show me the middle finger. Yeah. Okay, Farouk. Okay. Okay. Online students, what do you think? Ikri and Imran. And Daniel, 1 or 2? Just show me your finger. Ikri, 1, Daniel, or 2? 1 or 2? Just show me your finger will do. Or you're not sure? Okay, Daniel not sure. How about you, Ikri? Are you not sure? Okay, now you can actually check, guys. Okay, I think I shared this with the class previously. Okay, what you do is you check. This is 0.6350, right? This angle here. Whereas the basic angle is smaller. Okay, because it's smaller, it must be before, and therefore it must be 1. Okay, due to the fact that your basic angle, because basic angle is this angle here, right? This is your basic angle. It's smaller than 0.451, which is smaller than the dotted line, right? Yeah, so it must be before, not after. Okay, now as a result, what happens in this case? When you look at the domain, the start of the domain is the starting point here, right? The end of the domain is this dotted line here. Got any angles in between or not? Don't have, right? So what happens here? There's no solution. Okay, normally this is quite unique. Normally got solutions, right? Okay, this question here has no solutions. Okay, because as you can see, the angles all fall outside the domain. Okay, this is quite unique. Normally not this is not the case. Okay, but it's possible that sometimes there are no solutions. Can, guys? Okay. Okay, can I get you guys to try example 14? Okay, maybe we skip 14. We skip 14. Can I get you guys to jump to practice 15? That, you guys okay with part one? Do you all know how to get part one? Were you okay? No. Okay. How do we show that OT is this 1.6 cosine theta plus 0.5 sine theta? Okay, now this is an exam kind of question that you get for a typical exam question that you get for R formula. Okay, if you look at the previous example which we skipped, it's also about the same lah. Okay, you will be given some diagram, you'll be tasked to find some expression, okay, using the diagram. Okay, likewise here also the same. Okay, we were given the diagram, right, and then be tasked to find some expression. Okay, now to do this, right, to actually find out this expression here, you've got to make use of right angle triangles. Now, sometimes the right angle triangles are already drawn for you, sometimes they are not drawn for you. Okay, like in this case here, I can make use of this right angle triangle, right? Okay, remember, we are tasked to find OT. Okay, so if I were to use this right angle triangle OPQ, what can I get from here? Sorry? I can get OQ, right? I can find OQ. So go and find OQ first. That's where you use 1.6 and that's where you use the theta. And that's where your 1.6 cosine theta comes from. Okay, so maybe what I can do is to find OT, right? You can first split it up as OQ plus QT. Okay, how to find QT? We make use of this right angle triangle. Okay guys, in this right angle triangle, where's your theta? This, how you know is this one and not this one? Because this is 90, right? What's this angle here, guys? If this one is 90, means this and this must add up to 90, right? So if this is theta, wouldn't this be 90 minus theta? Which tells us that theta must be at R. Okay, they use this triangle here to help you find your QT. Can, guys? Okay, now even if also you cannot do part 1, right guys, please don't give up on the whole question, because you already have this expression for OT given. Use that to find your part 2 and your part 2. Okay, can I get you guys to try 2 questions as homework? You try practice 15 and practice 15 and 16, can? Can, guys? Okay. Okay, let me know if you need hints along the way. You have my number, you can text me. We'll go through soon. The plan next week is to go through the test papers, okay, that and then we move on to these 2 homework questions. I think that should be enough for one lesson. Can? Okay, questions to ask? Alright, okay, so yeah, just try out practice 15 and 16 at home. Yeah, okay, don't forget guys, tonight rather tomorrow night will be the webinar, free webinar for secondary students. So that will be from 7:45 to 9:15, completely free. So please try to sign up and attend this for just 1.5 hours tomorrow. Okay, alright, so looking forward to see you there tomorrow, and yeah, I'll see you guys for class next week. Alright, take care everyone, bye bye, enjoy the rest of your weekend, bye. Okay, bye Daniel, bye Kareem. Okay, bye bye Nazira.